Our next speaker is Sebnem Rusitschka. You started your career as a computer scientist, and in 2016 you started Freeelio. You joined a peer-driven initiative to create the free digital energy assets framework, funded by European Leisure Program, amongst others. And recently you joined EnergiMine as a CTO. So your background is energy, or your operating field. And your talk is about the step zero of designing and engineering a token economy, and you called it the TAO of token economies. Looking forward to your talk. Give her a round of applause.
Thanks a lot. I wasn't expecting the intro. So, yeah. So I'm going to give you the gist of what I came to see as the way to do token economies, coming from an applied researcher's field, and my application field is decentralized energy systems. And here's basically your way to cut it short, because I have to make up for sometimes for the great announcements that we're going to have after my talk. So step zero is you have to design your ecosystem in order to be able to formulate the assumptions. Those assumptions are what your model is built on. And if you screw up on those assumptions, well, you can use any technology and any framework you want, you're not going to get the desired result. But once you have your ecosystem designed and your assumptions there, you can model them. And you don't just model your system, you should model the system dynamics. Once you have that, you can run your simulations, and once that seems okay, you can deploy your smart contracts. You can embed those incentive schemes that you programmed into actual physical, cyber-physical systems like smart grids, smart microgrids. And when you do that, you are going to be able to datafy, meaning you are going to be able to get real-time data from the system that you just modeled. And with that data, you are going to be able to have model and data-driven optimizations, first of your system, but also of the outcomes you thought were good and were desirable, because that might change as well once you have deployed that. Now, let me just give the takeaways. You're going to model an evolutionary dynamics, and you will see that we live in non-ergodic systems, which means any step, any incentive, any action that is taken is going to change the system space and the potential outcomes. It's more like looking into contingencies and contingency analysis rather than trying to map the entire space. And all models are wrong. Some of them are useful, and the useful ones are the ones that tell you, no, you have been asking the wrong question, go back. Go back to step zero and think about whether you have the right ecosystem design. And I don't know, how many of you were now in the CAD workshop? Just two, okay. Then you should definitely find out about CAD, which is basically potentially a unified framework for that model and data-driven optimizations. Now, potentially because it currently can handle steps 1 and 2, but because it's a framework developed in Python, you can easily plug in your data pipeline from your actual systems and have that unified framework. Then you can rest assured that you can actually have insights into the systems that you are programming and deploying, and that are going to incentivize real people in the real world, and they're going to affect them. But you basically need to really take care about whether your design was right, whether you have included the right people in your system, and whether your system boundaries are set right to actually create the outcomes you hope for. And for that, we currently don't have a methodological way other than really running simulations and making, coming up with actually artificial economies. But you could, or you should, and coming from energy systems, you really have to utilize design thinking, and that's what I would call token design thinking. It's basically applied research on having token models, but actually embedding them into cyberphysical systems where you don't just have an automated microgrid, but also people interacting using the electricity from those systems. And I want to give a short example of the insights that we had from the Sun protocol, which was a token project until November 2018, and that's basically where I got to understand tokens and the power that we get a bit more, and the responsibility that we have. First of all, of course, you're solving for a problem, and that problem here was basically 600 million people in sub-Saharan Africa still don't have access to electricity after 150 years of electrification because it doesn't pay off in the existing systems with the existing incentive schemes. But there are already asset owners and operators, and that's what I would call an asset. And today I'm calling them digital energy assets because we can entirely digitize them. The Africa Green Tech is such a company that operates as solar microgrids in sub-Saharan Africa in many villages. And they can basically create an entirely digitized economies in these villages based off of renewable energy. The people get access to clean energy, to information system because it has satellite power, and basically when we tokenize those, also access to their own financial systems. And that's what I realized also through that project. When you tokenize energy, basically you're creating, if you want it or not, a monetary system, and you're creating a digital complementary currency in those villages that represents their GDP. And also it was very frustrating to see that we don't have any other KPIs in the economy other than growth. And the one thing that we saw immediately is basically that project could really use tokenization as a much better, as a much more usable way for incentivizing optimal use of the infrastructure, because a solar microgrid means that in the evening you have to get power from the battery, which is less effective. So you should use electricity when it's abundant, much of it during daytime, and at the night you should incentivize other types of electricity usage other than the productive types. And when we went into looking into that, we also realized incentivizing productive use of electricity is actually good. Good for the people because they use it in a way that generates income, but also good for the infrastructure because the capacity of the solar tinner is going to be ramped up much faster. So basically, you can have those token incentive schemes that are much more usable for the people because they're basically used to token systems already. They're mobile payments, and the way they access mobile communication is already tokenized, if you will, and when they enter the code, the same way they can top up their prepaid communication capabilities and their prepaid access to electricity. And once that happens, people know that this token is worth a couple of hours of communication or a couple of days of having access to electricity, and becomes a natural means of exchange for the people living there. Because it's really hard to get fiat money in sub-Saharan Africa because there are no ATMs around the corner. So it's actually a better system. And that was the takeaway. Tokenization makes this system better, especially in those villages. When we look at this community token contract that incentivizes the optimal operation, so it incentivizes the operator, and the optimal use of available solar energy in the villages, so it incentivizes the users, and it can be fed with the data from the smart meters and with other data that is available in the smart infrastructure of the solar tinner. So we can have an entirely automated system that is not just cyberphysical, but cybernetic. But what breaks and will keep breaking in every system that we're building is the investment side, the funding side of it. Because for that, we still need a lot of connections to the existing systems. We need the investors who come from a mindset that is not, well, that is still very traditional. And basically, I don't want to go into our design, but what we discovered just by mapping out the token model in this typical flow diagram, which is not even going into CAD yet. But you could already see what's going to be wrong with this token model when we deploy it, because we already see it in the model. This smart meter, this energy data, the oracle as we call it, will going to break because it's tech, or going to be broken quite often because that's where you can manipulate the system. The fiat token on-ramp will going to take a long time, and it's going to be very powerful once it's there. And the third case was, as I mentioned, on the investor side, it still means the investors, the contributors are sending their investment into places where actually there's a lot of risk of losing that investment. And these were the three models, and the third one you can't even really solve with tech, but you really have to change their mental models. And the insights that we got is, okay, we need to solve also, look for more systemic incentives to deliver the correct data, to protect the smart infrastructure, the oracle. We need to find ways, incentive schemes for governments not to freak out when there are digital complementary currencies through tokenization. And basically, the realization that got us to solve the next problem was these investors are actually ignoring the effect of their investment, the impact of their investment, because they say, okay, if I send money to high-risk areas, I'm going to lose that money. The risk is very high. If you don't send it, you will keep that risk high. But if you invest in crisis regions and they get this infrastructure, they get the stability, the economic stability as well, then actually that investment has effectively reduced the risk of losing the investment. So that's something we figured out impact investors don't yet see it, because they don't have this mental models of the business dynamics, of the investment dynamics that they do. So that meant for us back to step 0 and redesigning the ecosystem on purpose, because we want those infrastructures to be basically contributed towards, but we needed to solve for a lot of systemic incentives. And basically, we started that without the methodology, and I just found those people that could really make a change and help us with methods through the program that Angela also mentioned that is funded by Next Generation Internet, the Ledger program, and that is Ville, who designs business models for digital ecosystems. And it makes that in a way that we can actually use, because it's very similar to what startups and business developers are used to, but it's based on really research from Simone and Eleanor Ostrom, which we really need to incentivize and to wire the right incentives in these decentralized networks that we're building. And the good thing is, we can use that as an input specification for modeling with CAD/CAD. Now, if you don't know what CAD/CAD is, maybe it's going to be a bit tough. As I said, it's a modeling framework, but you basically need to figure out what your inputs are. And we can use Ville's research, or basically the templates that they're building, as a way to gather that knowledge, these requirements from the business. And I have to, okay. I wrap it up a little bit. So basically, you have to look for what's the highest value in your ecosystem. That's your ecosystem's missions, and you have to build your rainbow around it with the key players, the leaders, the contributors, the users of the system. And these are your agents and the outcome. And next, you can use the ecosystem member profile to actually map the value creation of each member towards that outcome. You have the characteristics, because that's going to rewire how they're going to behave naturally. You have the valuable assets that each member can contribute, and you have their valuable capabilities that will determine their actions in the ecosystem. And once you have that, you can plot what is called a motivation matrix, where you plot each agent or each actor in your ecosystem against each other and tell who is giving what valuable asset or what contribution to the other. And some may give and not get, and those may be the agents in your system that need to be given to through subsidies, for example, or through other means. And this is what CAD-CAD is called mechanisms. And the next step then, once you have mapped that, what will come naturally from who you included in your ecosystem, the intrinsic motivation for collaboration, you still need to see the corner cases and side cases and make this self-governance towards the outcome explicit. Because if you don't do it, no governance means bad governance. So, and this basically translates into what we call policies in CAD-CAD, and wiring that all up gives you your mechanism dictionary. And if you don't know CAD-CAD at all, you're going to be disturbed. But for those who are there, I hope this gives a nice intro into how am I actually going to use CAD-CAD, how am I actually wire that all up. Is basically you can come from these templates and have your functional requirements or your requirements specification in a way that that is needed for CAD-CAD, and you can start to code, run your simulations, run your Monte Carlo simulations, etc., and improve your system. So what happened basically is that we came up through token modeling with a better business model, that we enlarged our ecosystem because we saw we're not going to get the impact investors just by having that one digital energy assets in a crisis area, but we're going to get the impact investors over the edge if we can pool those digital energy assets in high risk but high social impact areas in developing countries with energy assets here in developed countries with more stable returns and revenue shares. So this was basically the aha moment that, yes, show me the incentives and I'll show you the outcome. That's so true. And now we have the tools to actually simulate those incentives and outcomes. So our ecosystem redesign, once we use those templates, also become, first of all, manageable by people who cannot code, but are perfect for business translation. So those behaviors, motivations, and policies are explicit and well documented. And once we have that covered, we have a requirement specification where the coders basically can use CAD-CAD as a framework to have programmable financial and programmable governance models, and that's a game changer. Because then we can literally A/B test our assumptions, and if they don't work out, we don't have to go out there and actually crash, but just rewire and redo. And by, as said, cyberphysical systems like solar microgrids are perfect for it, because we're also going to get real-time feedback from the system how people have been interacted with the incentives that we deployed. So we're not driving blind anymore. And also that means literally our economies right now are driving and blind and are driven by blind people. And that's something we should really change. Okay, and that's something I'm super bad at because still we're all in the systems, even if it's tokenized and programmed, it's still all too human. Means we have our mental models and that needs change as well, and we cannot just reprogram them in your favorite programming language. For that, I mean, look at the challenges. 2 of 3 is not something we want people to do, but we want people to change in their thinking. Don't freak out, okay? Don't ignore. And that means before we even can show them the results, we need to get them to understand. And you don't get people to change and understand by telling them to do so. So we need to create ways where the actors can actually become co-designers of the system, where they can have their own aha moments, because without them, we're not going to get anything changed in the all too human world. And what works always is play. And that's also something I just recently discovered, and that means Ledger is really a good community, because 2 great finds in 1 month, it's perfect, and it's even better than the funding we got from the program. So Federico, Bonelli, Fred, and Rafa, they came up in 2016 with this board game, this table game, basically makes people understand collaboration, coordination, commons, trade-offs, and actually be part of the system that we can now program and simulate, but they can actually experience the effect of their doing and non-doing directly at the table within a game. So you can look for Le Grand Jeu. It's on GitHub, and it's something I really think we have to look more into, because we're dealing with people who are non-programmers, and we want them to be part of it. We don't want them to be manipulated, to be incentivized in ways that they don't understand and they did not consent to, because that's what we're currently trying to do. And we need to talk. I don't have time, but literally that was the tip of the iceberg. And it's very deep and very broad. And I'm really happy that within a year we came together so much more experienced. And if we can have been able to manage that within 1 year, I'm really super excited for next year. And let's keep exchanging and talking and figuring out.
Okay, great, Sebnem, for this talk and for this, let's call to action as well. Thank you so much. This is your shirt. This is her Twitter handle, so feel free to connect with Sebnem.